Welcome. In this video, I want to see how we can represent a series using what we call sigma notation. So we are given a series, we have to represent it in another form, which we call sigma notation. Now, what is sigma notation? Sigma notation is just a notation where you use the Greek letter sigma to represent a series. So what are you supposed to do? You're supposed to say, we are starting from maybe term number 1 up to term number this position. So term number 1, we'll start from term number 1 there. Here you're going to put where you're starting from and where you're ending from. Okay, we are starting from maybe term number 1, maybe up to term number 10. So we need now to specify the formula here for predicting the position for each particular term. So what are we supposed to do here? First, we need to predict the formula for the nth term, the formula that predicts the term at each particular position. So what we have here is we have 20 as the first term, plus 40, plus 80, plus some terms in between, then the last term is this one. So we know this is the first term, we need to know this particular last term. But before we do that, we need to come up with a particular formula that predicts this term here for the first position, this term for the second position, third position, and so on. So if you look at this is term number 1, term number 2, term number 3. So you have to test if this is an AP, if this series is an AP or if it's a GP. Now, when you try those two, you see that it's not an AP, it's not also a GP. So what are you supposed to do next? You're supposed to inspect and observe what is happening. If you look at this, 10 can go there, 10 can go there, 10 can go there, 10 can go there as well. So maybe it's 10 multiplied by something. There's 10, 10, 10. In other words, this position is multiplied by 10, multiplied by 10, multiplied by 10, multiplied by 10. Now, if you look at these particular terms, you can observe something here. There is 10 multiplied by 2. This is the first position here. Then what we have on the next position, we have 10 multiplied by 2, again multiplied by 2. For this one, the next position, what we have is 10 multiplied by 2, multiplied by 2, again multiplied by 2. And this is position number 3, position number 2, position number 1. So here 2 is to the power 1, here it's 2 to the power 2 because we are multiplying 2, and here it's 2 to the power 3 for term number 3. So at each particular position, it will be 2 to the power that particular position, then multiplied by 10. So, in other words, if we try to simplify, the formula that is being observed here, it is 10 multiplied by 2 to the power n, where n is the position. So if it is term number 1, n will be equal to 1. So whenever there is n, I'll put 1 here, and it will be 2 to the power 1, which will mean 2. Then 2 multiplied by 10, I'll get back to 20. If I come at position number 2, it will be 2 to the power 2, which will be 4. 4 multiplied by this, I'll get back to 40. Then for this one, it will be 2 to the power 3 because this is position number 3, which will give me 8. Then 8 multiplied by 10, I'll be able to come to this. So now, we don't know this position here. We don't know this term number. So we need to predict the term number here. If this is maybe term number 10 or term number what, we need to predict this term. So we are going to use the same formula, but in this case, we know the term. What we don't know is the term number n. So we are going to say 10, 2 multiplied by n is equal to 40960. So now you simplify this expression so that you are able to know the term number here. This term, it is term number what? That's what we want to know. So here we can divide through by 10. You can divide through by 10. So we end up 2 to the power n. This will simplify with that. That will simplify with that. So we are going to have 4096. So if you are using a mathematics where you use calculators, you can use logarithms there. You introduce log there, you introduce also log there, and you should be able to calculate n. It will be the easiest. But if you are using a scenario where a mathematics where you don't use calculators, what you need to do is you need to express this one with the base 2. You need to say this is equivalent to 2 times 2 times 2 times 2, how many times? So we need to express this number as a product of 2's. Now, how do we do that? We will repeatedly divide this number by 2. Why are we doing this? We need to know where we are starting from, our addition, and where we are ending from. So this is the last term. We need to know the position for this term. We need to know if this is maybe term number 10. So let's express this one as 2 to the power something. So how do you do that? You need to repeatedly divide that number by 2. So I'll do just that. I'll put it here. I'll say 2. Then here what I have is 4096. 2 into there I'll get 20. 2 into there I'll get 48. Again, I'll continue this process until I get 1, so that it will be 2 times 2 times 2 times 2 a number of times. So 2 into that one we get 1, 2 into 0 we get 0, 2 into there we get 2, 2 into there we get 4. Then 2 there. Okay. Of course, if you've been doing a lot of mathematics, you've been trying to do these things, you can see that this number is the same as 2 to the power 10. But we can continue our divisions. So 2 into that we get 5, 2 into that we get 1, 2 into that we get 2. Okay, we continue this process. This will be 2. 2 into 11 we get 5. 2 into 12 we get 6. Again 2. 2 into that what we get 1, we get 2. 2 into 16 we get 8. Again we continue with our process here. 2 into 12 we get 6. 2 into that we get 4. 2 into this we are going to get 3, and then we get 2. 2 into that we get 1, then we get 6. Here 2, we get 8. 2 into 8, we are going to get 4. Okay, 2 into 4, we get 2. 2 into 2, we get 1. So when we multiply these numbers, these 2's, it will be equivalent to this. So in other words, how many 2's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in other words, 2 to the power n, if we have to get this number, it should be 2 to the power 12. In other words, this is the same as 2 to the power 12. So the bases are the same. The powers should also be the same. In other words, n is equal to 12. So n here is equal to 12. So this term here is term number 12. So we are adding a series starting from term number 1 up to term number 12, where the formula is this one. So now we can represent this using what we call sigma notation. So sigma notation, you use equal to. So we are starting from n equal to number 1, or term number 1, then you put up the formula here, 10, 2 to the power n. Then where are you ending? This term here is term number 12, so you put 12 there. And when you write this notation here, for this particular series, what you have here is what we call sigma notation. So basically, when you are told to write something into sigma notation, you need to know where you are starting from. The position here, this is term number 1, and where you are ending at, this is term number 12. Then you put up the formula that is predicting the terms. Normally, you have to try if it's a GP, if it's an AP, or you use inspection to come up with a formula just like what we did here. Once you come up with this formula, you need to know the limits, where you're starting your addition and where you're ending. Once you write something like this is what we call sigma notation. Thank you so much for watching, and for this and more videos, subscribe. Thank you.